All right, for our second day of two-step equations, we looked at a few examples that were more challenging. To kind of warm us up, we'll look at a few of our initial ones. So in a problem like this, both the 9 and the 6 have to move because there's our side with our variable. We're going to move the 6 with subtraction. We're going to move the negative 9 with division. And since 6 is further away from our variable, we start with the negative 6. We kind of go in opposite gems order. So negative 102 minus 6 gives us negative 108, leaving us negative 9b. We divide by negative 9 on both sides. The negatives cancel out. The 9's cancel out on this side, just leaving us our variable b. And 108 divided by 9 is 12. We throw division in there. We have the negative 2 that has to move, the 15 that has to move. The negative 2 we're going to add. The 15 we're going to multiply. Again, the negative 2 is further from our variable. The way we kind of determine that, when we talked about it in class, was if we plug in a number right here, say 30, what happens first? We would divide first and then go this way. So this was first. This was second. So when we solve an equation, we go in the exact opposite order. This goes first, and then this goes second. So whatever you would do first, you actually do last. So we add the 2, gives us n over 15 is equal to negative 1. We multiply 15 on both sides, n equals negative 15. For our final answer. Now, some of the more advanced problems that we looked at in class this week were what if it was written like this. So notice the slight difference between this problem's division and this problem's division. In this one, it's just the variable being divided. In this one, it's everything on the top being divided. So whenever we see that, we want to give this set of parentheses, and we're going to do all of this last. This is the last thing we're going to do, is anything up here. So the first thing we're going to do is get rid of that negative 3. Since it's being divided, we multiply. That gives us 15 is equal to 10 plus n. Well, now it's a one-step equation. How do I get rid of this 10? I subtract it, and I get my answer of 5. So whenever you see a fraction, we could technically add in parentheses to the top and bottom anytime we see it. But if we look at this problem, there's really no need to add the parentheses. There's nothing we can do with just n. There's nothing we can do with just 15. But in this problem, there is an operation that we could do if this number was like a 2 or something. But it's a variable, so we can't really do anything. So it has to go last in this case. For the same reason, the stuff on the top, we have to wait. We multiply by the 10. Leaves us n plus 6 is equal to negative 10 on the right. We subtract 6. And we get negative 16 for our answer. So when we have a fraction like this and everything's being divided, we have to get rid of this 10 so we could get to this everything. And we also looked at word problems this week. And so I have 4 of them that we're going to kind of look at today, all of different kind of styles. The things that we're going to be looking for in these problems is important information and what that important information actually means to the problem. So we have this 27. We have that magazines cost $2 and that each candy bar costs $5. So that's all pretty important information. This 27 represents the total, which means when we set up our equation, we're going to be equaling 27 in this case. Before we get started, we're going to define our variable. So it's going to be x. And x, what it's going to represent in the story is pretty much whatever that last sentence is in any word problem. How many candy bars did she buy? Boom, right there. How many candy bars? So X represents the number of candy bars. So if I put it here, so I have the number of candy bars that she bought. Well, it costs $5 per candy bar, like this. To know if we set it up so far correctly, you can kind of do some simple things like, what if she bought 3 candy bars? Well, 3 candy bars at 5 apiece, 5 times 3 is at 15, to kind of fit the model in our head. Yes. All right. She also bought a magazine for $2. That's just like a one-off price. She bought it. It's there. No big deal. Boom. Plus $2 for the magazine. So here's what she spent her money on. Now, how much did she spend is our total of 27. So there's our setup. We use the 5 with the candy bars. Notice that the 5 even mentions the candy bar, so it's even connected to the candy bars. The magazine was kind of its standalone price, so it stands alone, and it equals our total. To solve it, we subtract 2 from both sides. We get 5x equals 25. We divide both sides by 5. And so we get an answer of x equals 5. Well, 5 what? Candy bars. She bought 5 candy bars in this story. So Emily added 5 boxes to her move. A week later, half of her boxes were lost during the move. There are now only 12 boxes left. So how many did she start with? All right, once again, we're going to go through. So she added 5 boxes. She only has 12 boxes left, and half of all of her boxes were lost. Okay, and then the final thing is, how many did she start with? So that's what we're going to define our variable as. X is the boxes at the start. I should be even more specific, the number of boxes at the start. So she has some sort of boxes at the start. She added 5 boxes to that. But then she loses half of the boxes. Not just of the 5, not just how much she started with, she loses half of whatever this is, giving her 12 total left. We multiply by that 2 because we can't do anything with the top just yet. Get x plus 5 equals 24. We subtract 5 from both sides, and we get x equals 19. So she started with 19 boxes at the beginning of her move. All right, our next one. Kayla had $25 to spend on 4 raffle tickets. After buying them, she had $13. How much did each raffle ticket cost? All right, so let me grab my highlighter here. Go back to yellow. So she had $25 to spend. She bought 4 raffle tickets, and she had $13 left at the end. What we need to know is, how much did each raffle ticket cost? So the best part about word problems, that last sentence tells you exactly what our variable is. It's the price of a raffle ticket. So I'm going to put X right there. Now, what number up here related most closely to the raffle tickets? That was the 4. So she bought 4 raffle tickets. But when she bought those 4 raffle tickets, she got left with some of this money. So now we have to decide, is the 25 the total? Or is the 13 the total? So I like to think of the total as, at the end, what happened? Well, at the end, she had 13, so this is the total. So how do I relate the $25 that she started with the raffle ticket price to with the $13 she has left? Well, she started with 25. You have to subtract out the cost of the tickets to give you your total amount of money. There is another way to set up this equation. It gives you the same answer. You could also say that 13 plus 4x gives you the 25 that she started with. But notice the subtle differences here. Here you have 25 minus 4x. Here you have 13 plus 4x. It's as if I move this entire thing to the other side, and when it jumps ship, we make it a 4x. We already see that happening in our equations. If this was 25 minus 4, you could add 4 to both sides to get rid of it. So either one of those equations is perfectly acceptable to set up and solve. I'm going to use, it doesn't really matter which one. I kind of like the first one that I drew. We're pretty familiar with, I'm just going to get rid of that over here. Where's my, there it is. It's gone. I like this one. So I'm going to subtract 25 from both sides. I'm left with a negative 4x is equal to a negative 12. Divide by negative 4. And x equals 3. So she bought 3 tickets. Last word problem for this review video. So Chelsea was going to sell all of her stamp collection to buy a video game. After selling half of them, she changed her mind. She went and bought 12 more. How many did she start with if she now has 38? Alright, again, grab our highlighter. Important information. She sold half of her stamps, bought 12 more, now has 38. So the now has, this is our total here. And we have to use the rest of this. Well, how many did she start with? Oh, gotta grab my highlighter again. We have to know what we're going to define our variable. How many did she start with is going to be our variable. So x is the starting amount of stamps. So here's our starting amount of stamps, x. We don't know what it is, just some sort of number. She sold half of them. Got rid of half of them. Stopped selling them, decided that she wanted more, added 12 to her collection for a total of 38. We subtract 12, x over 2 equals 20, well, no, 24, 20, sorry, it's 26. 26, we multiply by 2 to finish out the problem. The 2's over here cancel. So x equals 52 stamps.